In this video, we'll be talking about WAEC 2021 Physics Practical, and our focus will be on question number 2. This is the second part of this series. So if you haven't watched the first part, I strongly recommend you check out that video because this is a continuation of that particular video. So in this video, we'll be talking about carrying out the experiment, and we'll also demonstrate how to plot graph and answer some likely questions related to question number 2 in WAEC 2021 Physics Practical. So let's get started. Mavinhub Physics Lab is a software application designed to simulate physics experiments virtually. You can download a copy by visiting our website at mavinhub.com. Check the description for details. So let's get started. So this is the experiment we are going to perform in this video. So just to recap, the goal of this experiment is to determine the focal length of a convex lens using lens formula method. And here you have the experimental setup, and here are all the apparatus that will be provided to you: convex lens, lens holder, ray box, a screen, and a meter rule. The idea behind the experiment is this: you place your ray box on the left side of the lens, of the convex lens. You fix the distance between the ray box and the convex lens. Then you will adjust the screen, which is on the right side of the convex lens. You adjust the screen until you have a sharp inverted image. So once you've got a sharp inverted image, you measure the distance between the convex lens and the screen. So that distance is denoted as V. You'll record that. Then the next step is to multiply U by V. Then the next step again is to add U plus V and record both values. Then you repeat the process again by changing U. So let's say the first value of U is 10. Then this time around, you change it, let's say, to 20 and to 30 and so on and so forth. So that's basically how this experiment goes. So let's get started. But before we do that, I would like to mention that in 2021 Physics Practical, question number 2, the focal length of the convex lens is meant to be 15. So WAEC expects you to be using a convex lens whose focal length is 15. In Mavinhub Physics Lab, you can actually set the value of your convex lens under the setting menu. So I'm going to head on to the focal length and change it to 15, since that's what we're expected to use in the actual exam. Then I'm going to leave this other setting as between 25 and 50. So what this means is the value of U will range from 25 or up to 50 with a step of 5. So I'm going to retain this. I'm going to set the time to be 30 minutes. You can change it if you have the software to any number that you desire. Okay, so let's get started. This is the simulation environment. So the first thing to note about this application is if you want to move the object, which is the ray box, you ensure that the U is highlighted. Then you can slide the slider up or down to move it away or closer to the convex lens. If you want to move the screen, you switch to V at the top here, then you move the slider to move it either closer or away from the convex lens. Then note that this white surface here is the front of the screen. So this is where the image will be displayed for you to know whether you've got an image or not. So let's take a look at what we expect the readings we expect to get. So we're expected to set U to be 25, determine the value of V, multiply U by V, and add U and V. So let's set U to be 25. That's the first thing we need to do. So we'll move this until we get to 25, until the distance between the ray box and the lens is 25. So here we've got 24.9, then we have 25. Then you switch to the screen and adjust the screen. You keep adjusting until you get a sharp image. So now we've started getting an image, but it's not sharp enough. They keep adjusting. Okay, now it's getting a little bit dull. So you bring it back until you are confident that you've got a sharp image. So let me adjust a little bit. Okay, so let me stop here. This is the sharpest I can get. So the value is 37.5, the value of V. So what's the product of U and V? So you can get that with a calculator. So just multiply 25 by 37.5. So that will give 937.5. So let's just paste it. So the next is to sum 25 and 27.5. So this will give us 62.5. So the next is to adjust the ray box to 30, to a distance of 30 from the lens. So let's switch back to U and increase the distance between the ray box and the lens. So here we have a distance of 30. So let's go back to the lens, to the screen, and adjust it until we have until we see a sharp image. So now we've got an image, but let's adjust it until it is sharp enough. So I think it's around 30. If you move lower than 30, it's getting duller. If you move above 30, it's getting duller. So it's roughly around 30. So let's see. Okay, this is the sharpest I can get. Okay, so the value is 30. The value of U is 30. If you multiply 30 by 30, you're going to get 900. And if you add them up, you get 60. So let's move on to the third reading. So that's where U is 35. So we switch back to U. We move it up to 35 and we adjust until we've got a distance of 35. So the distance between the ray box and the lens is 35. Then we switch to the screen and adjust it until we've got a sharp image. So let's check this out. This is getting clearer. Then let's see where it gets dull. Okay, so it's somewhere around here. So let's adjust until we've got something that is sharp enough. So this seems to be the sharpest I can get. Okay, let me move it up a bit. So let's say 26.2. So that's 26.2. So let's multiply 35 by 26.2. So 35 times 26.2. So that's 917. Then when you add this up, you're going to get 35 plus 26.2. That gives 61.2. Let's move on to the third reading where we have U as 40. So when U is 40, let's move it up. So 40, when U is 40, so that's the distance between the ray box and the lens. What's the value of V? So let's adjust V until we've got a sharp image. So the image is getting duller, so it's somewhere around here. So let's check this out. So it's roughly 24. Let me increase it a little bit. So it's roughly 24. So let's have this as 24. If you multiply 40 by 24, you will get 960. So this is 960. Then if you add them up, you will get 64. So let's move on to the third reading, the fifth reading rather. So that's when our object distance between the ray box and the lens, when it is 45. So let's increase or move it away from the lens until we get 45. Then we adjust the screen until we get a sharp image. So this is getting duller, this is sharp, getting duller, so it's somewhere around here. Somewhere around here. So let me adjust it a bit. So we have 22.5, roughly 22.5. So let me record it as 22.5. Then I'm going to multiply 45 by 22.5. So that will give this, which is over 1,000. So I'm going to record the answer as this. Then let's add the 2 up. That will give us 67.5. And lastly, the sixth reading, we move the object distance to 50. Then we adjust the screen until we get a sharp image. So this is somewhere around here. This is somewhere. It's getting duller. It's getting, so it's somewhere around here. So this is around 21.5. So let's record it as 21.5. So let's take a product of 50 and 21.5. So that's 1075. 1075. Let's add them up. That will give 71.5. So now we've got our readings. We've got all our readings. After getting your readings, the next step is to plot your graph. From the instruction in the procedure, we have to plot u plus v against u times v. So u plus v will be on the y-axis, while u times v will be on the x-axis. So let's go to the graph section. You can do all your plotting right on this application, the Mavinhub Physics Lab application. So this application guides you on how to plot a proper graph, a proper experimental graph. So the first step is to define your title. Every graph should start with a title. You should know what a title is. So in this case, our title is u plus v against, or you can say versus, u times v. What label are you going to have on your x-axis? The label should be the value or the variable of on your x-axis. So in this particular instance, what will be on the x-axis is u times v, which is uv, and the label on the y-axis is u plus v. So the next thing you need to figure out is the scale on your x-axis and the scale on your y-axis. I'm going to talk about how to make a proper scale in a separate video, but for now I'm just going to quickly describe how to go about the scale. The first thing to know is you need to look at the range of values in your x and y axis. So this is the x-axis, while this is the y-axis. Since the minimum value is 900 and the maximum value is 1075. Whatever scale you are going to make should be within that range. So it should be within that range in such a way that all the points all the points on your graph must be found on your graph sheet. So since we've got a minimum of 900 and a maximum of 1075, so if I take a difference between them, I'm going to get about not up to 200 but close to 200. Then if I divide that by, let's say, 10 for instance, so I'm going to get 20. So what that means is the spacing should be roughly 20. But note that I'm going to explain in detail how to come out, how to get an acceptable scale. So in this case, I'm going to use 20 as my step, but my starting point will be close to 900. My starting point will be close to 900. So I can start from, let's say, somewhere around 860, for instance. Then my maximum can be to 1100, then with a step of 20. So this has not reflected yet. So this is 860 to 1100 with a step of 20. Note that your scale is not a must that your scale should start from zero. If you have a case like this where the minimum value is very far away from zero, your scale may not have to start from zero. So your value, the starting point might be greater than zero. Then the next is the y-axis. On the y-axis, the minimum value is 60 and the maximum value is 71.5. So I'm going to start my starting point should be close to 60 and my ending point should be close to 71. So we can start anywhere from 40 to, let's say, about 80. So let's say our maximum is 80 and our minimum is 40, and we have a step of, let's say, 10, but we can break it further to have a better division, which is 5. Okay, so this is the scale we are going to use. So on the x-axis, we are going to use a step of 20, while on the y-axis we're using a step of 5, but the starting point on the x-axis is 860. Now that we've defined our scale, it's now time to do the plotting. The first step in doing the plotting is to locate all the points that you have on your reading, is to locate them on your graph. So let's take the first point. Where we have UV as 937.5, U plus V is 62.5. So where UV is 937.5, which is somewhere here, our U plus V is 62.5. So let's trace 62.5. This 60, each small step is 1. So this 62, which is this, then 0.5 is here. Then we've got our 937.5, which happens to be here. So we just click. But before you click, you have to highlight this pencil to indicate that you want to actually locate a point. So now I'm going to go back here, which is this. Then I'm going to click. So the next is when we have 900, when UV is 900, which is this. The other one is 60. 60 in the sense that the U plus V is 60. So 60 is here. So we click on this point where they intersect. So the next is where we have UV as 917, so 917, which is somewhere here. This is 916, then 917 is somewhere here. Then the U plus V is 61.2. 61.2, this is 61, then 0.2 is slightly here. So just slightly above this 61.2. So let's just click this. Then the next is where we have UV as 960. So here you have 960. U plus V is 64. So where do we have 64? Just below 65. So this is it. Then the next is where we have UV as 1000, 1012.5. That's 1000. This is 1012, which is here. 0.5, which is a little bit above it, beyond it. Then we have 67.5. 67.5 is here. So this 67, then 0.5. That's right at the middle. So here you go. So this is where it's located. Then lastly, where we have UV as 1075, this is 1075, which happens to be here. 1075. You have U plus V as 71. So where is U plus V, which is 71 here? So it's somewhere 71 is 71.5 is here. Then 1075 is slightly, so this is it. This is it. Yeah. Okay, so next is to join the points with a straight line. To do that, you just to use your ruler and just join the point. But on this software, I'm going to use this tool. Just click the graph line tool, then you can join them. So to join, you just start from anywhere, then you click on anywhere, then you begin to move your mouse until you are okay with the with the with the line. Ensure that the line touches as many points as possible or is as close as possible to all the points. So I'm going to click on this point to indicate I'm done. So the next thing to do is to figure out your slope. So to do that, I'm going to pick 2 points on this. I'm going to pick 2 points on I'm going to pick 2 points on this my graph. So this is my point 1 and this is my point 2. Then I'm going to indicate the value there. So at this point 1, the y is 60 and the x is 900. So in this case, y1 is 900, x1 is y1 is 60 rather, and x1 is 900. That's value on the x-axis. Then y2 is this, which is 65.5. So that's 65.5, and the corresponding x value is 980. 980. So what's the difference between 65.5 and 60? The difference is 5.5. Now what's the difference between 980 and 900? The difference is 80. So what's the slope? The slope is change in y divided by change in x. So that is simply 5.5 divided by 80. So this is going to give 0.06875. So that's 0.06875. Okay, so the next, we are done with the graph. So do note the sequence of events. The first thing is to define your scale. Next is to locate your points on the graph, draw the graph line, determine your slope, and that's it. You are done with your slope. So let's move on to the likely questions that may be presented to you. So these are some of the questions that may be asked. So the question you may be asked is to calculate the focal length f of the lens using the slope we derived from your graph. So essentially this is you looking for the reciprocal of the slope. So the slope we got here, let's take a look at what we got earlier. We got a slope of 0.06875. So let's determine the reciprocal of that. So that will give us roughly 14.5, which is actually very close to the focal length we set earlier. So this 14.5. So the next question could be that you use your focal length to calculate to determine the power of the lens. So this question is designed to determine if you can calculate the power of the lens. So I would like you to figure that out. Go and read up on what was the power of the lens and figure that out. Then later we will look at the correction. Then the next question to answer is if the image created by a projector on a screen in a cinema is virtual. They're asking if that statement is true or not. So can we say the image created by a projector on a screen is virtual or real? So the issue is the question is testing your ability to know what a real image is and what a virtual image is. A virtual image cannot be caught on a screen. So anything you can view on a screen is actually defined as a real image. So in this case, the image created on a screen in a cinema is not virtual. It is actually real. It's a real image. So in this case, this is false. This statement is false. Okay, so we are done with the experiment. So once again, note that all physics experiment in WAEC involves you performing the experiment proper, taking readings along the line, plotting graphs based on your reading, plotting a graph based on your reading, and answering some questions based on the result of your slope. So I'm going to submit and show you how Mavinhub Physics Lab grades experiments. Okay, so my results is out and I performed fairly okay, which is 88.3%. Mavinhub Physics Lab gives you a detailed analysis on how you perform on various aspects of the graph. So for instance, my performance in readings is quite okay, which is 100%. Axis, not quite okay. I made some approximations. Then the graph points, perfectly okay. Then my graph line, very okay. Then my slope, 100%, and question and so on. So the question here is, you can master. The question is, how do you gain mastery of physics practical? You can use Mavinhub Physics Lab to do that. It grades your ability to perform various aspects of physics experiment. So here's the time I spent. So I spent the vast majority of my time on the graph section. So now you've got the reading and the correct reading by the side. So this is my reading. This is the actual reading. So this is when I say actual reading, that's the perfect reading. The perfect reading is determined by the simulator. Note that in WAEC you may not get exactly what uh, might be obtainable theoretically, but they expect it to be as close as possible. So in this case, the simulator will grade me as correct if it's very close to the actual answer. So here you've got the graph, and this is my graph, and this is the simulator. This is the graph generated by the computer. So this seems to be more appropriate than the one I defined here. But note that I will talk more about that in a separate video about graph. Then these are my graph components, the minimum value that I provided and the minimum value recommended by the simulator. Then it also shows the slope, my slope and that of the simulator. Then here we've got my performance in the question section. So my answer is 14.5 and the actual answer is about 15, which we expect since that's the focal length of the lens. So, but that's very close to the actual answer. Then in this other case, I did not attempt it, so I got it wrong. In this case, I attempted it, and that's the right thing. So let's look at correction. You can check out the correction after performing the experiment. So in this case, there's an explanation on why the answer is real. So the answer is real because it can be caught on a screen. If it can't be caught on a screen, then it's virtual. Then I can also check for other ones. So this is the answer for the second question. So the power of the lens is 100 times 1 over the focal length, so which will give you this. So note that the 100 is because of the conversion to meters. So that's the essence of the 100. So if you convert centimeters to meter, then you'll get this factor. So here we've got the answer for the focal, length. In the next video, we will discuss and experiment the second likely question that can be set from the experimental apparatus given to you.